What we're going to be working on today is looking at some homework problems that I've had people ask me about. And so what I chose to do is list this as Chapter 1 through Chapter 3.2 review. This will hopefully be able to help you when you are reviewing for your 9 weeks test. The first thing we're going to look at is Lesson 1.2. And in Lesson 1.2, what I chose to do is write the equation in standard form. So what we're looking at first is y equals x minus 5 times x plus 3. Now standard form is y equals ax squared plus bx plus c. And so what I have to do is I have to FOIL. I'm going to multiply x times x, which gives us x squared, x times a positive 3, which gives me 3x, a negative 5 times x, which gives me a negative 5x, and a negative 5 times 3, which gives me 15, a negative 15. Now with this, all we do is combine like terms. I have a negative 3, a positive 3 minus 5x, so that gives me a negative 2x. I'm going to bring down my x squared, and I'm going to bring down my negative 15. And so here, y equals x squared minus 2x minus 15 is standard form. Now we're going to move on to number 2. And this time it's it should be y equals 5 times x plus 3 squared minus 4. I need to rewrite that so I understand that I'm going to be FOILing. So I'm going to say 5 times x plus 3 times x plus 3 minus 4. Now I can see that I need to FOIL. X times x gives me x squared. X times 3 gives me 3x. 3 times x gives me 3x. And then 3 times 3 gives me 9. I haven't done anything with my 5, so I'm going to bring it down. And I haven't done anything with my 4, so I'm going to bring it down. I want to go ahead and combine like terms. And again, I haven't done anything to 5, so I'll bring it down. X squared, 3x plus 3x gives me 6x plus 9 minus 4. Now, I want to distribute this 5 to everything inside the parentheses. So I have 5 times x squared is 5x squared. 5 times 6x is plus 30x. 5 times 9, which gives me a positive 45. Now I can say minus 4. So the last step is going ahead and combining these two like terms. So I have 5x squared plus 30x. 45 minus 4 gives me plus 41. So y equals 5x squared plus 30x plus 41 is the standard form of 5 times x plus 3 squared minus 4. The next review I want to do is by factoring the expression, which is lesson 1.3. Again, I took these from the homework. They are not questions 1, 2, and 3, but they are the 3 that I want to talk about concerning factoring the expression. So the first one I have here is x squared minus 7x minus 18. Remember that when we factor, we want to put everything that we know as soon as we know it. So I can go ahead and put parentheses. And because this is just x squared, I can go ahead and say x times x. Now what I have to do is figure out the factors of 18, which we have as 1 times 18, 2 times 9, 3 times 6. And out of those factors, I need one of them to be a negative, and for it to total when they're added together to equal a negative 7. Because this is a negative 18, and the middle is a negative 7, my highest factor is going to have a negative sign. So if I say a negative 18 plus 1, that doesn't give me 7. If I say a negative 6 plus 3, that doesn't give me 7. But when I say a negative 9 plus 2, it does give me a negative 7. So I can say minus 9 plus 2. And I have now factored x squared minus 7x minus 18. The next one I want to look at is x squared plus 9x minus 36. Again, we're going to take the information that we already know. Because this is just x squared, we could do parentheses. And we could go ahead and say x times x. That is what we know. Again, I need to find the factors of 36. So I have 1 times 36. I have 2 times 13. I have 3 times 12. 4 times 9. 6 times 6. So with this one, I have a negative 36, but I have a positive 9. So what I want to do is keep my highest factor being a positive number. And so if I say 36 minus 1, that does not give me 9. If I say 13 minus 2, that does not give me 9. If I say 4 minus 9, that does not give me 9. 6 minus 6 does not give me 9, but 12 minus 3 does. And so I can say plus 12 minus 3. And again, I have now factored x squared plus 9x minus 36. The last one we want to look at with factoring the expression is x squared minus 36. I can see with this one it's going to be a little different because I don't have just a plain x. I don't have a bx area. And so what I'm going to do is I'm going to rewrite this as x squared minus, I can rewrite 36 as 6 squared. When I see it in this form, it's almost like a special pattern. It's not considered one, but it's kind of like it. Because what I can do is say x minus 6 in one parenthesis and x plus 6 in the other parentheses. The reason why is because if we were to FOIL this out, I would say x times x gives me x squared. X times 6 gives me a positive 6x. A negative 6 times x gives me a negative 6x. And a negative 6 times 6 is a negative 36. You can see when it's FOILed that this positive 6x is canceled out because of this negative 6x. So anytime you have just two terms and they are both squared, when it's a negative in between them, when the operation is a negative, you can go ahead and say, okay, well, I can say one of the factors is a positive and one is a negative. And they're going to be the same as long as we have squared and squared. And that is how you factor the expression of x squared minus 36. The next thing we want to look at under lesson 1.3 is solving an equation. This can also be called finding the zeros. Now the equation I'm going to use is x squared minus 11x plus 30 is equal to 0. Again, I want to go ahead and place everything that I already know. So I put my parentheses. Because this is x squared, I can say x times x. Now I need to find the factors of 30. We have 1 times 30. We have 2 times 15. 3 times 10. And 5 times 6. Because the 30 has a positive sign, but the 11 has a negative sign, that means that both of these factors are going to be negative. And so, if I say a negative 30 minus 1, that gives me a negative 31, so that's not 11, a negative 11. A negative 2 minus 15 gives me a negative 17. Again, it's not a negative 11. A negative 3 minus 10 gives me a negative 13. I'm getting closer, but it's still not a negative 11. So I look at a negative 5 minus 6, and it does give me a negative 11. So I can say minus 5 and minus 6. Now, once you have the factors, you have to set them up equal to 0. So x minus 5 equals 0. You want to solve for x. That means I'm going to add 5 to both sides. So x equals 5. Same thing with x minus 6 equals 0. I want to solve for x, so that means I'm going to add 6 to both sides. So x equals 6. Now we have solved the equation and found the zeros of x squared minus 11x plus 30. Moving on to lesson 1.4, we are now going to be factoring ax squared plus bx plus c. What that means is when we factor, we're going to have a number that is attached to the squared variable. So this first one, we have 49 n squared minus 16. Now again, this brings in one of what I considered a special pattern from lesson 1.3, even though it's really not, because I can see that 49 is 7 squared, and then n squared, and then 16 is 4 squared. And there's a minus between. So I can rewrite this as 7n squared minus 4 squared. That way I understand that this 7n together will go in both parentheses. So again, because we're factoring, I set up 2 parentheses. And since I have this is squared, I can say 7n and 7n. Because the 4 is squared, I can say 4 and 4. And remember from the last one from last lesson, because it has a negative in here, but it does not have a bx, that means I'm going to have one as an addition and one as a subtraction. That way the bx gets canceled out. And so that is how you factor 49n squared minus 16. Now we're going to look at the second one, a negative 36n squared plus 48n minus 15. The first thing I want to do is try to factor out any monomial that I can. And so I'm going to look at 36, 48, and 15. And I can see that they all have a 3. But I don't want this to have a negative. I don't want my factor to be a negative. So I want to go ahead and divide all of this by a negative 3. Which will mean that my negative 3 goes on the outside of the parentheses. A negative 36 divided by a negative 3 gives me a positive 12n squared. 48n divided by a negative 3 gives me a negative 16n. And then a negative 15 divided by a negative 3 gives me a positive 5. Now what I want to do is to begin factoring. But because I have an a that's not 1, I have to find the factors of 12, which are 1 times 12, 2 times 6, and 3 times 4. And then the factors of 5, which is 1 times 5. What we have to do is decide when they are multiplied together, these the first factors with the last factors, and then they're added together, they have to equal this negative 16. So what I'm going to do is I'm going to look and say, okay, well if I do a positive 1 times 5, that gives me a positive 5, plus 12 times 1, that's not going to give me a negative number. I need it to be a negative. So what I'm going to be doing is looking for something that's going to give me negatives. So now what I want to do is say, okay, well why not do a negative, how about if I do a negative 2 times 5, well that does give me a negative 10. And then a negative 6 does give, times 1 gives me a negative 6. So a negative 10 plus a negative 6, that does give me a negative 16. Because what I did is a negative 2 times 5 plus a negative 6 times 1. That gives me a negative 10 minus 6, which is equal to a negative 16. So now I have found my factors. A negative 3 is brought down. I'm going to do 2 factor sets of parentheses. Now, I did a negative 2, so I can say a negative 2 times, or how about, why don't I do, I could probably go ahead and do a negative 5 times 2, because that will still give us the negative 10. So let me go ahead and do that. I want to go ahead and have this as a positive, and then I want to do my negative 5. And here's an N and here's an N. Now, I want to do a positive minus 5. This one, I'm going to go ahead and say minus 6. Minus 6n, or 6n, and then minus 1. So I have found, when I FOIL this back, I can say 2 times 6 gives me 12n squared. 2 times a negative 5 gives me a negative 10n. A negative 1 times 6 is a negative 6n. And a negative 1 times a negative 5 is a positive 5. So 12n squared, when we combine like terms, is a negative 16n. And then plus 5. And that's what we have up here. So is negative 3 times 2n minus 1 times 6n minus 5 is the factor of a negative 36n plus 48n minus 15. Moving on to lesson 1.5, we are going to be simplifying radicals. And remember that a radical is, the radical sign is the square root or any kind of root symbol. What is underneath it, which in this case would be the 28, is the radicand. What we want to do is see if there is any perfect square within 28. So within 28, can we do 4 times 7? So I will rewrite this as the square root of 4 times 7. That now we can go ahead and say, rewrite this as the square root of 4 times the square root of 7. And knowing that the square root of 4 is 2, we have our answer as 2 square root 7. So the square root of 28 is 2 square root 7. On number 2, because the radical covers the top and bottom of a fraction, we can rewrite this as the square root of 18 over the square root of 11. There's not a perfect square within 11, but we can't have a radical in the denominator. And so what we do is we say we have to rationalize the denominator, which means we are going to multiply top and bottom by square root 11. What that does is replaces, and we can say 18 times 11 over the square root of 11 squared. 18 times 11 gives me I think it's like 189. 198. I had my numbers backwards. So the square root of 198 over, and the square root of 11 cancels the squared, so over 11. Now, can we find a perfect square within 198? We can, because we can go ahead and take out 9. So if we were to divide this, and I'm going to go ahead and write it down here, we can say 9 times 22 over 11, which again can be written as the square root of 3 times the square root of 9 times the square root of 22 over 11. And we know that the square root of 9 is 3, so we can say 3 square root 22 over 11. And that is the simplified radical of square root of 18 divided by 11. Now the last one we're going to look at is 2 divided by 1 minus square root 3. What we're going to have to do here is multiply top and bottom by the conjugate radical. What that means is we are going to multiply top and bottom by 1 plus square root 3, 1 plus square root 3. Now again, this is considered the conjugate because we have a negative. We want to cancel it out, so the only way to cancel out the middle when we FOIL is by doing the opposite operation, which is plus. And so I can go ahead and rewrite and say 2 times 1 plus square root 3 on top. And then on bottom I can FOIL it. 1 times 1 gives me 1. 1 times square root 3 gives me a positive 1 square root 3. A negative square root 3 times 1 gives me a negative 1 square root 3. And then square root 3, a negative square root 3 times a negative square root 3 gives me a negative 3. Now again, these cancel out. And so what we are left with is 2 times 1, which is 2, and then plus 2 square root 3, all over, we have 1 minus 3, which gives me a negative 2. So we can rewrite this as 2 divided by a negative 2 is a negative 1. And then 2 divided by a negative 2 is again a negative 1 square root 3. And there is your simplified radical form of 2 divided by 1 minus square root 3. Now we're going to look at lesson 1.6, which involves solving the quadratic equations and writing complex numbers. So the first thing I want to do is look at 2x squared plus 31 equals 9. What I want to do is get everything I can that's not attached to my x over to one side. So that means I'm going to subtract 31 from both sides. That leaves 2x squared equal to a negative 22. Negative 22. Now the next thing I want to do is go ahead and get rid of my 2 that's attached to the x. So again, the opposite of multiplication is division. So I'm going to divide by 2 and divide by 2. So I have x squared equals a negative 11. The last thing I want to do is my square root, or my squared, which means I'm going to have to square root both sides. But when I square root both sides, because it's an even, we have to write it as a plus or minus the square root of a negative 11. Now I see that my x is by itself, but I have a negative inside my radical sign, which cannot be. And so to get rid of this negative sign, we have to write it with an I. So x equals plus or minus I square root of 11. And that is solving this quadratic. Now, the next thing I want to do is to write complex numbers. One thing to keep in mind is that there is an operation that is separating these two parentheses. So what that means is I'm going to rewrite this as 14 plus 7 plus 3i plus 6i. 14 plus 7 gives me 21, and then 3 plus 6 gives me 9, and then I'll just attach my I. So to write this complex number and simplify it, it is now 21 plus 9i. The next part of 1.6 that I want to talk about is writing an expression in standard form. And so I have the equation of 8 minus 3i times 8 plus 3i. So what I want to do is FOIL. 8 times 8 gives me 64. 8 times a positive 3i gives me a plus 24i. A negative 3i times 8 is a negative 24i. And a negative 3i times a positive 3i is a negative 9i squared. Now, one thing we have to keep in mind is that I squared is the same as saying a negative 1. So I'm going to go ahead and rewrite 64. And I know that 24i minus 24i cancels out. So I can say minus 9 times a negative 1. A negative 9 times a negative 1 gives me a positive 9. So 64 plus 9 will give me 73. Now the next thing I want to do is find the absolute value of a standard form of a plus bi. Find the absolute value of a plus bi. And so what they gave us is the equation 7 plus 7i. The way to find the absolute value of a complex number, which is a plus bi, what you have to do is say the square root of your a, which is 7 squared, plus your b, which is 7 squared. So I now have the square root of 49 plus 49. We can rewrite that as saying 49 times 2. So square root of 49 times 2. And we can rewrite again to separate those as the square root of 49 times the square root of 2. We know that the square root of 49 gives us 7, and there's no perfect square root of 2, so our answer is 7 square root 2. That is the absolute value of 7 plus 7i. The next lesson is 1.7, where we talked about completing the squared. So I'm going to look at 3s squared plus 6s plus 9 equals 0. What I want to do is get rid of any monomial, divide by any monomial that they all have in common, 3, 6, and 9. So I can see that I can divide all of this by 3. So that's going to give me s squared plus 2s plus 3 equals 0. Now with completing the square, remember what we want to do is we want to move our 3, which is our C, over to the other side of the equal sign. So we're going to subtract 3 and subtract 3. So I have S squared plus 2S equals a -3. Now, the next thing I want to do is to take half of my B, which is 2. Half of my B, which would be 2 divided by 2, gives me 1. And then I square that, which still gives me 1. But I want to go ahead and put it as 1 squared. So a -3 plus 1 squared on the other side, because what you do for one side, you have to do for the other side. Now I can rewrite this as saying S plus 1, all of that squared, equals a -2, because a -3 plus 1 is a -2. From here, I need to get rid of my squared. And so I'm going to square root the whole side, and which means I'm going to square root the other side. But again, that means S plus 1 equals plus or minus the square root of a -2 because of it being a squared. The next thing we want to do is get S by itself, so that means this 1 will get subtracted and subtracted, so I have a -1 plus or minus the square root of a -2. However, I see that I have a negative sign. Because there's a negative sign in my radical, I have to make that come outside, and the way we do that is by saying a -1 plus or minus I square root 2. Because remember, your I outside of a radical replaces the negative inside of a radical. In lesson 1.8, we learned how to solve a quadratic equation with the quadratic formula. So what I did is I went ahead and wrote the quadratic formula on the board. A -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I have 3x squared plus 7x minus 24 equals 13x. The first thing I need to do is write this into standard form, which means this 13x has to come to the other side, which means we're going to subtract. So now I have 3x squared plus 7 minus 13 is a -6x minus 24. Now this equals 0. So I now have it in ax squared plus bx plus c form. My 3 is a, my b is a -6, and my c is a -24. And I got this because, again, this is ax squared plus bx plus c form. So now we can go ahead and put it into the formula. I have a minus a -6 plus or minus the square root of a -6 squared minus 4 times 3 times a -24. All over 2 times 3. The first thing I want to do is say a minus a -6 becomes a +6, plus or minus the square root. And a -6 squared is +36. And then I have 3 times a -24. That gives me a -72 times 4. So a -72 times 4 gives me a -288. So minus 288. Oh, sorry, plus 288, because a minus negative times a -4. And then all of this is over 2 times 3, which is 6. 288 plus 36 gives us 324. And then we have the square root of 324. And again, we still have our 6 plus or minus over 6. The square root of 324, if I was to think about this, we should be able to look at it in, say, let's see, 9 squared would be 81. I know 15 squared is 225, so 16 squared, maybe, let's try 18 squared. So if we wanted to do 18 times 18, that would give us 64. So we have 4, we have 2, and we have 324. So I can rewrite this as saying 6 plus or minus the square root, 16 plus or minus 18, because we just found that 18 times itself gives us 324 over 6. Now what I'm going to do is break it into 2 sections. 6 plus 18 over 6 and 6 minus 18 over 6. 6 plus 18 gives us 24, divided by 6 gives us 4. So there's one answer. And then 6 minus 18 gives us a negative 12, and a negative 12 divided by 6 gives us a negative 2. And there's your 2 answers when we solve using the quadratic formula.